Hey everyone, what's up? Welcome to another episode of Pacific Arc Tig Welding. My name's Dusty. For today's episode, we're gonna do some TIG welding pulse settings. I did an episode about a month or so ago where I welded some really thin stuff. I got a lot of messages and a lot of people commented on the video that they wanted to see how to set up pulse for a joint similar to that. So today what we're gonna do is we're gonna go over some pulse settings. I'll throw a little disclaimer out here first because if you watch several videos on YouTube, you will see very quickly everyone's got their own kind of setup going. So I'm gonna throw it out. This is my setup. This is my kind of preferences. You can watch a couple other videos out there from different channels. They will give you slightly different advice. I'm not saying my advice is the best advice. It's just what I do. So again, try what you want. See how you like certain settings, whether I recommend some stuff or you watch a different channel stuff and you see different settings. Try it all. See what you like. Everyone's got their own preference. Everyone's got their own setup. So just try it for yourself and see what you think. So the first thing I'll do is probably go over a little bit of terminology here. Sorry, boring stuff, but it might make a little bit more sense if you hear this out. So pretty much every machine now, there are a few machines out there that have a fixed pulse setting. And so what I mean by pulse is that when you're setting up a machine and you press down the foot pedal or you flick the thumb trigger to start your arc, what'll happen is you have a high amp and then you have a low amp. So what'll happen is you'll have a cycle, and in that cycle, it will cycle on at the high amp and then it will cycle down to the low amps. Most machines, there are a few out there that are fixed to a certain amount of time. So 1 pulse per second or whatever they may be, and they may be a certain percentage that they're stuck at. So you may have 100% on your high amp setting, and then you may have whatever, like a 50% or 40% or even lower set at the lower. But with most machines, what you can do is you can really customize all that stuff. So that's what we're gonna go over today. So on a machine, what you can do is you can set your high and your low, and what you can do is in that cycle, you'll set your high amp for whatever you'd like. So when you press down on your foot pedal, 100% of your foot pedal down will be up to what you set it here for your amperage. Then the second part of the equation is the low amp setting. So you can set your low amp setting very, very low, so it drops down to almost nothing. Or you can set it to about, I prefer somewhere around like 40%, where it'll be a low current for sure, so you'll have a drop and it will cool the material in between pulses, but not so low that when it goes back up to the next pulse on the high end, it has to reestablish itself. So I find somewhere around 40%. Again, you can play with this yourself. It does change with different tungsten setups. I'm running a 332 tungsten today for aluminum. So again, it will change for everything that you do. This is just what works well for me. So my general rule of thumb of something I prefer doing is 1 pulse per second. Pretty simple. It's just something that works well for me. I like to set up my pulse range or my pulse cycle for about 40% on the high amp and then about 60% on the low. So what a longer percentage on the low amp does is I tend to find that it causes more what's called puddle freeze, so that when it cuts to the low, it will cool down very quick, which is really nice. So if you're ever working with really, really thin stuff, where you're kind of doing fuse welding, you're fusing without filler rod or something like that, I generally find that a longer percentage on the low cycle tends to cause the puddle freeze a lot better. It makes it look a lot nicer, which is pretty sweet for something where you're not using a lot of filler rod. Your puddle freeze on the low amp setting will really help you get that kind of bead look, which is kind of what we're after here. So first off, when we're not running any pulse setting, so we're just running an open foot pedal or thumb trigger or whatever, and you're just running an open setting, this is great because what you can do, obviously you see me do it in my other videos and stuff like that, is I use the fill and my stepping motion kind of as the way I'm gonna create my weld shape and the way I'm gonna create the bead look or the dime look or whatever you wanna call it. What tends to happen is when I'm cruising along and I'm welding with my filler rod, I just have an open setting, so my foot pedal's down, whatever the setting may be. And what I'm doing is I'm stepping, fill, step, fill, step, fill, step, fill. So when I'm doing the stops and I'm putting the fill in, that kind of acts somewhat like a puddle freeze. The reason that this happens is because I'm putting filler rod in. Filler rod acts as a little bit of a cooling agent, not much for sure, because you're still running an open amperage and you're just hitting it with filler rod. The filler rod does, however, allow the heat to go into the weld itself and not the parent material as much. It will go into the parent material for sure, but this will cause it to cool down just a little bit. And then what happens is when I do those little stops for each step, like so, that acts as the puddle freeze. So the puddle freeze will let the weld sit down a little bit. Even though I'm putting filler rod into the arc, when I stop, it gives it just that split second where it will sit down and it will actually keep the shape of that round puddle form, which is what you want. So what will happen is that we add pulse to this factor. The low amp setting will act as that puddle freeze. So if you're ever doing something where you're not using filler rod, so if you're ever welding some thin stuff, some sheet metal where you're just doing edge to edge or something like that, what you'll do is you'll set up your pulse setting so it will create the arc and it will wed the material together, and then that low amp will cause that puddle freeze, and that's exactly what you want. When you get it set up properly, you'll be able to get that dime look really, really nice, and especially on thin stuff like that, it's pretty hard to do. Again, watch the video. I'll put the link in the description below where I welded some really thin stuff. We did some 040, which is like less, I don't know, I think it's like barely a millimeter thick, but I used filler rod on it, and I just tried to run it without pulse. It worked pretty good. Obviously, it took a little more time to get it set up. However, if you're running something without filler rod, it's nice to have it set up with that low amp so you get that puddle freeze, and that way you get that real nice bead look on the edge of something that thin. So general rule of thumb of what I like to set up as far as pulse goes is 1 pulse per second. Keeps it pretty simple. I have a pulse setting where on the high side of it, it's usually about 40%. On the low side, it's about 60%. A little bit longer will allow more time for that puddle freeze, which is good. Especially something this thin is you want more time to let it cool down. The advantage of pulse on pulse obviously is that when the pulse is off, there's not as much heat going into it. So with something this thin, you're gonna cause a lot less distortion, which is awesome. And then also on top of that, you're gonna be able to give it that puddle freeze time so that it lets the material cool down a little bit, and you get the bead look on the edge of your weld, which is awesome. So the next kind of range for pulses per second are anywhere between 5 pulses and 30 pulses, generally from what I see on other people's videos that they talk about. I can't stand this range. How is that? It drives my eyes crazy. You can set something up anywhere between 5 to 10 pulses a second, all the way to 30 pulses per second. And I literally, you can set it up for yourself, I can't focus. It drives my eyes really crazy. I'll get as close as I can with a super clear lens in my helmet, and I can't focus. It drives my eyes insane. So I find anything between that range, so anywhere between, let's call it 5 to 10 pulses per second, all the way to 30 or 35 pulses per second. I just won't even bother with it. It just drives my eyes crazy. So beyond that, let's call it between 35 pulses per second to about 100 pulses per second. I find this pretty sweet. The pulse rate is almost imperceptible because it's happening so fast that it doesn't bother my eyes. And the benefit to this is you actually still get that puddle freeze because you are incorporating that low amp part of the cycle in there as well. It's happening a lot quicker, so it's not gonna cool down as much as if you were running 1 pulse per second or something like that. But the benefit to this is if you're ever welding like 1/4 inch or something like that, and you're welding like a corner to corner joint, if you are setting it up for something that quick, somewhere anywhere between 35 to 100 pulses per second, you're not really gonna notice the pulses a lot, but you're still gonna get that puddle freeze, which is really nice. So if you're ripping along at a pretty quick speed and you're just feeding it material, it's gonna do a lot of that puddle freeze for you. You won't have to focus on stepping as much, I find. Again, that's my opinion, but that's usually what I find. So it's really good to incorporate a faster pulses per second rate for something where you're gonna be moving along a little bit quicker, and you're not gonna give it the time to do the individual steps and stops in that weld pass. So probably everything that you've seen on my channel so far. I'll show a couple clips right now of me welding some art pieces with stainless steel and stuff like that. I have not used a pulse setting for any of these pieces. I do foot pumping with my pedal, and what this is again, I'm just manually pushing down with my pedal each time. The reason I like doing this is because sometimes I want longer pulses at the high range, and I want some shorter ones at the high range as well. So when you set up a machine, it's so literal. It follows a timer basically. So if you're working with something like an art piece or something like that, where you actually need a kind of a variable rate where you can change it, instead of going over to mess with the machine and mess with all the dials all the time, I'll just do it with my foot. I'll just pump down with the foot pedal, and it helps out a lot. It lets me make up my mind as I go, which is a lot nicer. So what we're gonna do today is I'm gonna set up some really thin stuff here. This is 060 material. I'll put on the screen what that works out to in metric as well. But what this stuff is we're gonna set it up for a little corner to corner joint here. And I'll show you how I'm gonna set it up when we tack it together. But a little interesting thing I learned in putting this episode together is that I'm not gonna use filler rod for this one. So what this is called is when you're actually just using the material to fuse itself. It's called autogenous welding or autogenous welding. I don't know, autogenous welding sounds pretty good, so we'll go with that. However, because this channel is all about keeping it simple, I'm just gonna call it welding with no fill. So let's get set up. We'll set the machine up here, and then we'll go over that, and then we'll tack this stuff together, and we'll go from there. Okay, so let's set up the Everlast here. This is the Everlast 210 EXT. There we go. So let's get her set up here. So we definitely don't need 180 amps for something this thin, so let's turn this down quite a bit. I don't even know where we'll go. Let's go about 140, just leave it at that. So what we're gonna do is we're gonna turn on our pulse here. I'm just gonna use the standard AC/DC, which is pretty good. It's pretty simple, straightforward. Okay, so let's check out our settings here. So what I'm gonna do is I'm gonna set it up just for the sake of trying it. We're gonna do 50% on, and the low amps, the bottom of our pulse here, is going to be at 30% of our total 140 amps. And then the amount of time that we're going to do is about, let's just do about a half a second or something like that. We'll do about a half a second on off. So let's see. So yeah, it'll be about a half a second. So a half a second on, half a second off. Everything else is pretty straightforward. Our balance, let's back that off. Be about 30% positive. No down slope. Pulse flow, about 4 seconds. There we go. So here's our material here. It's nice and clean. We're just gonna wire brush it a little bit more after we tack it together. But what we're gonna do is we're gonna make sure that when we tack it together, again, this is preference, this is just what I like doing. But when I'm gonna do something without filler rod, instead of doing like a corner to corner joint like so, I like to overlap it. Now this is a technique you'll see done with some sheet metal and stuff like that. Some people do it, some people don't. But what we're gonna do is, because we're gonna be doing this without filler rod, I want to make sure that we get as much of the material into the weld as possible. So if we were to put it corner to corner, again, which is fine, but what will happen is that when you fuse it together, it will have to cover more of a distance to fill that weld gap. However, if you overlap it slightly, like so, you'll have more material that will create the weld joint for you. So it'll tend to be a little bit stronger. Okay, so first step is let's tack these plates together, and then once we go from there, we'll give it a whirl. So we want to make sure that we're overlapping slightly like I talked about, just like that. We're going to arc up and tack it together. We'll try and give it a good tack too. Okay, now we got our plate ready. We're going to tack it together and we'll go from there. One thing I will say is that what I'll be using is a Pyrex cup. The Pyrex cup is just so you watching can see a little better. I actually don't use Pyrex for aluminum welding. The reason I don't like doing this is that if I dip or anything like that, the splatter will wreck the glass. So I'll sacrifice a cup for you guys today. Hopefully I don't dip. So I want to make sure that when I tack it together, we're overlapping slightly like I was talking about, just like that. And we'll just try and give it a decent little tack here. There we go. For that side I used a little bit of filler rod, and I actually will dab up my first side here again with a little bit more filler rod, just so we have a little more material to start from. There we go. So we got it tacked together now. I'm going to wire brush it real quick, but then I'm going to turn the pulse back on. The same settings as we went for there, so it'll be about half a second on, half a second off, and then yeah, we're just going to run it with no fill. We're going to see how it goes, but I have a feeling this one should turn out pretty good. There we go. So we got most of the crap off the surface there. There's no more oxide or anything like that. It looks pretty clean, so we will roll with that. So what we're going to do here is we're going to start on this side on the left here, and because I'm left-handed obviously. I'm going to travel across like this, but the reason I added a little bit of filler rod just for the tacks is that I just want to give myself a little more to stand on at the beginning until I get the puddle exactly like I want it to be, and then I'll roll out from there. But I just use a little bit of filler rod to tack up usually, just because I want to make sure that I have a little bit of meat to use basically to start the weld with. So what we'll do is we'll start on our edge here, and then I'm going to go to about halfway. We'll stop and see how it's going, and then we'll finish it off after that. So we'll just do the first half to start with. Okay, so first half, here we go. I'm going to really focus on getting it perfect at the start. So you'll see the pulses kick on, And what I'm going to do is I'm just going to let it sit right on the edge of this tack here until I see it exactly drop down how I want. And then once it's good to go, then I'm going to roll out. All right, here we go. Okay, so as we see here, it turned out pretty decent. Everything sat down really nicely. Definitely one thing I will mention is when you're doing this and you get set up with the rhythm and everything that you like and it's sinking down the way you need to, watch how much distance you put between your steps. Generally what I like doing is I like laying down a puddle and then I move on so that I only expose about 1/3 of that puddle that I just did. So I have about 2/3 of the puddle will be covered up by the next puddle and about the first third of it will be exposed. And then you get a bead that looks pretty decent like that there. Now, a couple things we can check is we throw a ruler across it like this. You can see that it's sitting down nice and flush. We don't have any kind of rollover or anything like that where the weld is spilling over the edge. We can check it with a ruler like this and we make sure that nothing is too proud on either side. It looks like it's rolled over pretty well. The weld is sat down quite a bit. If you were to have too much spillover or something like that, you would have a ruler that's raised up slightly like this. And that just meant that the weld had spilled over a little bit too far onto one side, but this one looks pretty good. So again, we'll check this next side over here. Again, sitting pretty flat, which is good. And if we flip it over to the other side, you can see we just have almost a perfect amount of penetration there. It's just laid down perfectly where it's come through. Very slightly, which is good. You just have that slight rippling. However, we don't have any burn through it like excessively, which is really good. So the whole consistency of that setting is pretty good. I'm happy with that. So let's set it up and we'll finish the second half now. Okay, so nice and comfy and we'll work our way towards the end here. And here we go. Okay, so there we go. We wrapped it up, continued the puddle on pretty good, but this is basically just a good kind of example of how when you get a machine set up decently, with a good fit up, it pretty much just flows really, really nice. So all you have to do is kind of babysit it as it's running. So again, flipping it over, our penetration looked pretty much good the whole way. Our tie-in right in the middle there, wetted through perfectly almost. It's like very even penetration throughout the whole thing. So overall, I'm pretty happy with this guy. I would definitely dial it in a little bit more, but overall, for how thin this material is, I'm pretty stoked on that. So there you have it. This is a basic setup. Again, there's a couple things I didn't like about the way it welded. However, overall, this is a good demonstration of the time that you take to get used to the rhythm and a rhythm that you're comfortable. And then most importantly is get your joint fit up properly. Joint fit up is definitely the most important part of pulsing something this thin. So make sure you take the time to make things fit together properly. If you're fabbing up a joint or anything like that, make it fit nice and tight for something like this. But again, this is just an example of the way I do things. Like I said, I would take a little more time if this was an actual project and get everything dabbed up properly. Might even use a little bit of fill here and there just to stop it from getting too hot in certain areas. However, good example. If anybody else who's watching has suggestions or anything they'd like to shout out, leave it in the comments below. I always like learning new stuff. I always like seeing how other people do things too. This is just the way I do it. I'm not saying it's the perfect way, but this is a pretty good example of generally how people will set up their machines for a little job like this. So again, thank you so much for watching. Please subscribe, like, share. I always feel bad asking, but that stuff helps my channel grow. The more people that watch these videos, the more videos I'll make. Again, I have a website. Please check it out. There's stuff on my website about my art gallery, all things I've done with TIG welding. I have a blog now, which is kind of interesting. I've just started doing that, so there's only a couple entries down there now, but a little bit of information about my online course where I'm helping people online learn how to TIG weld, real basic stuff. But if you're looking to get going with TIG welding, check out that website. There's resources there. Again, thank you so much for watching. I really, really appreciate it. I hope everyone's cool out there. Reach out, let me know how you're doing. Leave comments below. I like chatting with people. But yeah, other than that, have a good one. Peace.